The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Today, our guest is Jennifer Barton, Professor of Biomedical Engineering, Electrical and Computer Engineering, Optical Sciences, and Agriculture and Biosystems Engineering. She directs the U of A's Interdisciplinary Bio5 Institute and the UA Health Sciences Sensor Lab. Because her research has an unusually broad impact, she's been recently elected as a senior member of the National Academy of Inventors, on top of her many other honors. Congratulations on that, and welcome, Jennifer.
Thank you. It's my pleasure to be here.
Essentially, you help physicians and scientists to be able to see inside us, to detect tiny abnormalities in various tissues in our bodies before deciding, say, whether to do surgery. Give us a general overview of these really high-tech innovations you've made.
Well, we know that we want to detect disease early, especially diseases like cancer, because the earlier we can detect it, the more curable it is. The problem is when diseases like cancer are early, they're very small, so we need something with high resolution. Well, advances in technology and light sources, fiber optics, detectors have made it so that optics have the sensitivity and the resolution to be able to detect this early disease. The challenge is with optics that it just can't see through us. We're not transparent. So we have to be able to get our light sources and detectors very close to the tissue that we want to image. Therefore, I started working on miniature endoscopes that can go through these natural pathways in the body through your esophagus and colon and fallopian tubes.
When did you realize how significant this breakthrough might just be?
Well, around the turn of this millennia, there was a huge explosion in technology of new fiber optics and new lasers and light sources that were no longer taking up an entire table in a laboratory somewhere, but were little boxes you could carry around with yourself. And that's really when biomedical optics started exploding. We realized that we could take this technology, we could make it small, we could make it appropriate to bring into a doctor's office or an operating room, and we could further miniaturize endoscopes so that they could go into all these small areas of the body without having to do any sort of tissue cutting at all.
So I'd like to ask you about this falloposcope that you're developing, that you can get into fallopian tubes in situ, so that the doctor can look inside at a level of detail that was never possible before. Tell us about this.
The ovarian cancer is now known to actually start in the fallopian tubes. And when we discovered that, and with the technology advances and miniaturization, we realized that we could make an endoscope that would go through a natural pathway in the body up through the uterus and into the fallopian tubes. The fallopian tubes are only 1 millimeter in diameter, so we need to get something that's the size of a couple human hairs and build all the optics and detection we need into that endoscope so that we can image inside the tubes.
And that will allow you to go into all sorts of other body parts. What do you see as a future for the technology you're developing?
Yeah, the smaller we can get, the more places we can go. So looking inside the eustachian tubes in the ears, the pancreatic and bile ducts to see where cancers might be starting there. As you mentioned, inside blood vessels or inside the little bronchioles in our lungs down to deep areas to look for lung cancer.
That's absolutely fantastic. Well, this is very exciting, Jennifer. Congratulations on this huge step you've taken technologically.
Thank you.
Jennifer Barton's a leader in developing advanced imaging methods and applying them to a variety of important health problems. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.